Welcome back, guys. Today we're going to take a look at topic 8.2, which is solving systems of equations algebraically. In our last lesson, we did a quick review of systems of equations from grade 10. We also were introduced to linear quadratic systems and quadratic quadratic systems. And then we worked on solving equations or solving systems of equations graphically. So when we're solving systems, we can solve graphically or we can solve algebraically. And today we're going to look at the algebraic methods. Now, when we're solving algebraically, there are two methods that we can use, substitution and elimination. And we went through both of these in grade 10. We're going to go through them again this year. And what we noticed already last year when we were working with systems of equations is that certain systems lend themselves better to substitution or elimination. So I'm going to take you through both steps. I'm going to show you some examples of equations that may be better suited for substitution or elimination. And then we're going to do a few examples. So unless you're asked to use a specific algebraic method, you're going to look at your equations and then decide which method is the most appropriate. So solving with substitution, this is our first method. So when we're solving using substitution, our first step is to rearrange one of our equations to isolate a variable, take that expression, sub it into the other equation, solve for our unknown, sub back into the original equation, and then we have our solution. So it's called substitution because we're essentially subbing in and out of equations. Now, when we were working with linear systems last year, it really didn't matter which equation we started with. Often I told you to stick with the KISS method and pick whichever was easier. Now, when we're working with quadratic equations, it's important that we take a look at our equations and see which one has the quadratic term. Now, a quadratic term means x squared or y squared or a squared or b squared, depending on what variables we're using. And so in this case, the quadratic term is the variable x. So we're going to rearrange our linear equation. And when we're working with substitution, that's pretty much always the case. We're going to rearrange our linear equation. So here we have 5x minus y equals 10. And because x is the quadratic term, we're going to isolate y. So we move the y over, bring the 10 back, and we have y equals 5x minus 10. Now, at this point, we're going to take that 5x minus 10 and we're going to substitute it in for the y value in our quadratic. So this 5x minus 10 is going to sub in. I kind of think about volleyball when I'm thinking about substitution. This x squared plus x minus 2y is our court, and we're subbing in a new player for y. So y player is coming out and 5x minus 10 player is going in. All right, so now at this point, we're just simplifying. So we're going to multiply that negative through. Remember, when there's a negative, you got to be careful to bring it through to both terms. So make sure that you have a positive 20. And that leaves us with x squared minus 9x plus 20. At this point, we're factoring. So we have x minus 4 and x minus 5, meaning x equals 4 or x equals 5. Once we have those, then we're going to go back to our original equation, the first one that we rearranged, and solve for our y values. So here we have x equals 4. I'm going to sub in 4. I have 5 times 4 minus y is 10. Rearranging my equation, I'm going to have y equals 10. Now, if x is 5, we also need to sub in for that one, and we'll find out that y equals 15. At all points, we need to verify our solutions. If we are solving algebraically, then we're going to verify graphically. If we're solving graphically, we're going to verify algebraically using left side, right side. So if I have my solutions of 4, 10 and 5, 15, I would be graphing my original equations on my calculator to check to see if these are my intersection points. Now, when we're looking at equations, again, some are going to lend themselves better to substitution or elimination. When we're working with substitution, we want to find one that's easily manipulated or could be easily rearranged. And also we want to avoid having a lot of x squareds or quadratic variables. So here we have an x squared minus 16x equals y and y equals 2x minus 1. Well, this lends itself really well to substitution because I'm just going to take that 2x minus 1 and I'm going to pop it in for the y there. So I'm going to substitute it in. This is my new player that's being replaced on the court. Now, if we take a look at this system here, notice that both equations have quadratic terms in them. So this is not going to be as easy to rearrange and isolate a variable and not get really messy in the process. All right, now let's take a look at our second method for solving algebraically, which is elimination. Now, elimination is also sometimes called addition or subtraction in some books, or some videos will call it addition or subtraction, because essentially we are adding or subtracting our equations. But it's known as elimination because our ultimate goal is to eliminate one of our variables so that we can solve for the other variable. Now, here we're given a system of equations. Notice that they both have quadratic variables. So this is going to be a good one for elimination. The first thing we're going to do is line up all our terms. Make sure that all the terms that have the same variable and the same degree are set up. So I'm going to line up my x squareds, line up my x's, line up my y's, and line up my constants. Notice it doesn't matter what side of the equation they're on, just as long as all of the same degrees are lined up. Now, since the quadratic term is x, we're going to eliminate the y term. So again, it doesn't matter what my variables are, whichever one is the quadratic, I'm going to eliminate the term that is not quadratic. Now, if I take a look at these two equations here, if I want to eliminate my y's, notice that my top equation has a 2y and my bottom equation has a 1y. So ultimately what I want to do is multiply this entire equation by 2 so that my y value will have a value of 2. Now that needs to happen to the entire equation. If I only multiply part of the equation, I've now changed the value of that equation. So you can bracket your entire equation and multiply it through a 2 through, or you can just multiply by a 2 on each side. Either way, you should end up with 4x squared plus 2x equals 2y and minus 8. And once we have that, then we can set up our two equations again. So I have 6x squared minus 3x equals 2y minus 5, and I have 4x squared plus 2x equals 2y minus 8. Now, these equations are these variables 2y and 2y are the same, so in order to eliminate them, I'm going to have to subtract. So I bracket my equations and I subtract. Now, 6 minus 4 is 2, so I've got 2x squared, and negative 3 minus 2 is negative 5x. 2 minus 2 is gone, so that disappears, it's eliminated. And negative 5 minus a negative 8 is positive 3. Now, there are some books out there or some resources out there that don't ever subtract, they only add. And the way to make that happen, if you don't like working with subtraction or those negatives cause you trouble, when you were multiplying up top here, you would have to multiply by a negative 2 to make your 2y and your 2y have opposite signs. And so that is a strategy that's often used. I do usually just make them look the same and then add or subtract as needed. All right, once we have 2x squared minus 5x equals 3, I can just move everything to one side and factor. So I have 2x squared minus 5x minus 3 will become 2x plus 1 and x minus 3. And then solving, I have x equals negative 1/2 or x equals 3. Again, just like in our last step, I'm going to take those x values, sub them in, and solve for y. And again, our last step will always be to verify our solutions. Because I solved algebraically, I would probably verify graphically using my calculator. Now, just like in our previous example, there are some systems that are set up better for elimination than for substitution. Again, if you see those quadratics, if both equations have a quadratic, you definitely want to do elimination. If you're looking at a system where I already have one of the variables rearranged, then substitution makes the most sense. At this point, this would be really easy to take 4x squared minus 5, sub it in for y. Whereas for my first equation, I would want to be using elimination so I could get rid of my y's. In this case, I would just add my equations together. I'd eliminate those y's and then be able to go ahead and solve for x. All right, so that takes us through both types of algebraic methods, both substitution and elimination. Now we're going to take some time to actually practice. This might be a good opportunity for you to pause the video, do these practice questions, and then come back and check your answers. All right, so our first question here, we have 3x plus y equals negative 9 and 4x squared minus x plus y equals negative 9. In all cases, we're being asked to solve algebraically. That means that we have to use substitution or elimination, and we're asked to verify our solution. Because we're solving algebraically, I'm going to check our answers graphically. All right, so taking a look at this equation here, we have to decide which method makes most sense. Well, if I notice here, I have I have a linear equation and I have a quadratic, so substitution is probably a good method. It's going to be really easy to isolate that y. I'm isolating y because my quadratic variable is an x squared. So my first step is going to be to rearrange that top equation. That gives me y equals negative 3x minus 9. Now, once I have that, my next step is going to be to take that negative 3x minus 9 and sub it in for y in the next equation. And so I'm going to take that 3x squared minus 9, and it's going to pop right in there for the y. So I have 4x squared minus x plus, in brackets, negative 3x minus 9 equals negative 9. It's usually a good idea to use those brackets whenever you're substituting, especially when there's a negative involved. Now, simplifying, I'm going to have 4x squared minus x minus 3x minus 9 equals negative 9. Now, you'll notice nothing really changed there because I had a positive, but if that had been a negative, those brackets would have been really helpful to avoid silly mistakes. So here we're going to have 4x squared minus 4x minus 9 equals negative 9. You may have been able to skip this step and jump right to the next one, but I want to write them all out here as we go. So 4x squared minus 4x, I will have added 9 to both sides, and a negative 9 plus 9 would have given me 0. Now at this point, I am going to factor. Anytime we have those quadratics, so we have two variables, we're almost always factoring. So I'm going to pull out a common factor here. I'm going to have 4x times x minus 1 equals 0. And moving through to solve, that's going to give me 4x equals 0, or x minus 1 equals 0. And that gives me x equals 0, or x equals 1. Now I'm going to take those values and I'm going to sub them into my original equation. So my original equation was 3x plus y equals negative 9. So I'm going to start with x equals 0. So if x equals 0, I'm going to have 3x plus y equals negative 9, giving me 3 times 0 plus y equals negative 9. Zeros cancel out, and I've got y equals negative 9. So one of my solutions will be 0 and negative 9. Now, if x is 1, I'm going to do the same thing. 3x plus y equals negative 9. I've got 3 times 1, and that gives me 3 plus y equals negative 9. Subtracting 3, that gives me negative 12. So my other solution should happen at 1 and negative 12. So that means I have two solutions. Now, if I want to verify my answers, I'm going to graph. So in order to enter these equations into my calculator, I'm going to have to rearrange. Notice I have 3x plus y equals negative 9. So that would give me negative 3x minus 9. And for the other equation, I can just keep the y where it is, move everything else to the other side. So that will change some signs. That'll give me negative 4x squared plus x and minus 9. Now I can graph and check my intersection points. For this particular graph, it's intersecting quite low, so I might adjust my window settings. I know that one of the intersection points is at 1 and negative 12, so it probably makes sense to adjust my window settings so that my minimum goes a little bit lower. And so then I can find those intersection points. Second calc 5, enter, enter, enter. 0, negative 9, and then a little bit of a trick. I know the next one's supposed to happen at 1, negative 12, so I'm just going to trace at 1. And when I do my intersection point, all this is going to do is verify it. But it helped me move my cursor closer to that point right away. And so that other solution is correct. So when I'm verifying, I'm just going to do a quick sketch just to show that I found those answers. And my intersection points are happening here at 0, negative 9, and 1, negative 12. All right, so let's take a look at our next example here. So we have y equals 1/2 x squared minus 4x plus 12, and y equals negative 2x squared minus 12x minus 23. Now looking at this, I have two quadratics, so I want to use the elimination method. So my goal is to make these two look the same. Because my quadratic is an x, I want to get rid of the y. So I'm going to make both of my y's look the same, and I'm going to multiply by 2. The reason I'm doing that is because in the end, that's also going to help me get rid of my fractions. So while the y's already look the same, multiplying both equations by 2 is going to help me get rid of that fraction. So this is going to give me 2y equals x squared minus 8x plus 24, and 2y equals negative 4x squared minus 24x minus 46. Now my y values have the same sign, so I'm going to subtract. 2y minus 2y is going to leave me with 0y, essentially 0. And then I've got x squared minus a negative 4x. So 1 minus a negative 4x is 5x squared plus 16x. So negative 8 minus a negative 24 is plus 16x plus 70. So 24 minus a negative 46 is 70. So I now have 5x squared plus 16x plus 70 equals 0. Now, as it turns out, this particular equation is not factorable. And if we wanted to verify that, we could go back and use the discriminant coming from a different unit. If I have b squared minus 4ac and it comes out to be less than 0, then it's not factorable. So if I didn't know that at first, I would first start by checking for a GCF. There is no GCF I could pull out, and I would probably then I would use my guess and check method. Again, would have trouble finding anything. So my next step would probably be to go to the quadratic. So before jumping into the quadratic, we would use our discriminant just to see if it's even factorable. And so if you remember, we have an a b, and a c. So plugging those into the discriminant, I would have 16 squared minus 4 times 5 times 70. And if I actually calculate that out, I'm going to have negative 1,144. Now remember that b squared minus 4ac is what's under the square root sign. We can't square root a negative, so this is not factorable. Now again, because that's not factorable, that means there's no solution. And again, to verify, we're going to use our calculator. All right, now once we have our equations typed into our calculator, then we're going to hit the graph button and see what we have. Now taking a look at the graphs, we already knew from before that our leading coefficients told us that one was opening up and one was opening down. This shows us that not only do they open in different directions, but because of their y-intercepts, they're completely separate. They will never cross. If you go back to the quadratics unit, you may have already been able to predict that there was going to be no solution, again, based on the fact that the graphs are opening in different directions and their y-intercepts are significantly far apart. This bottom equation here is opening down and the y-intercept is below the x-axis, whereas this one is opening up and the y-intercept is above the x-axis. So using what you know from previous units might help you to predict whether a solution is even possible. So sketching our diagram here, we're going to show that we have one graph opening up and one graph opening down, and there is no solution. So taking a look at one more example here with the methods, we're going to look at 2x plus y equals x squared plus 5 and y equals 4x. When we look at this equation here, we have a linear and we have a quadratic. One is already rearranged and set equal to y, so it would make sense that we start off with substitution. And I'm going to take this 4x right here, and I'm going to just sub it in for y. So that gives me 2x plus 4x equals x squared plus 5. Simplifying that gives me 6x equals x squared plus 5. And then I can rearrange my equation so that everything is on one side of the equation. So that's going to give me x squared minus 6x plus 5 equals 0. At this point I can factor. That gives me x minus 5, x minus 1 equals 0. And I have x equals 5 and x equals 1. Now again, I'm going to take those values and I'm going to sub them into my y equals 4x equation. So when I have x equals 5, that gives me y equals 4 times 5, which is 20. And when I have x equals 1, that gives me y equals 4 times 1, which is 4. So my solutions would be 5, 20 and 1, 4. Now, it is really important that when you're doing your solutions, you don't mix up your coordinates. I've seen it happen quite a few times where students will have x equals 5 and y equals 20, but then they'll write their coordinate as 20, 5. It's really important that it's written x, y. So again, we have our equations, x squared minus 2x plus 5. So I've just brought the 2x over, and y equals 4x. Graphing this, we're going to have our quadratic and our linear. We can check our solutions. So second calc intersect, enter, 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 gives me 1, 4. Again, I know that my other intersection should happen at 5, so I could trace at 5. And even though I can't see it on screen, it will still give me my solution. If an x value is not on screen, then I would have to adjust my window settings. So I have my other intersection happening at 5, 20. And just sketching my solution there. I have those two intersection points. And I'm not too worried about scale. Again, it's just to show that you understand the overall shape of the graph and where those intersection points are occurring. All right, so now we've done a few examples on substitution and elimination. Let's take a look at how this would work with applications. So in our first question here, we're asked to find some unknown values. Now, in this example, we're asked to determine the values of m and n if 3, 4 is a solution to the following system of equations. Well, if 3, 4 is a solution, that means 3 represents x and 4 represents y. So what we're going to do is substitute x and y into our equations and solve for m and n. So starting off with our first equation here, we have mx squared minus y equals 32. I'm going to sub in my x and my y, and I'm going to solve for m. Now, taking a look at these two equations, why might have I started with the first equation? Well, if you notice, I have an m in the first equation and an m and an n in the second equation. Since I only know the values of x and y, it makes sense to start with the equation that only has one variable. So substituting in, I'm going to have m times 3 squared minus 4 equals 32. Simplifying, that gives me 9m minus 4 is 32. Rearranging my equation, I'm going to have 9m equals 36, so I'm adding 4 to both sides. And then dividing both sides by 9, I'm going to have m equals 4. Now I can take that information and sub it into the next equation, which is mx squared minus 5y equals n. All right, so I have m is 4, so I can sub in the 4. I know that 3 is x, so 3 squared minus 5 times 4 is equal to n. So that gives me 4 times 9, which is 36, minus 5 times 4, which is 20, and that gives me 16 equals n. So that gives me n is 16 and m is 4. Okay, guys, so one more example here. We're going to take a look at a number problem. So in this problem, we're told that a cargo plane drops a crate of emergency supplies to workers on the ground. The crate drops freely at first, but once the parachute opens, the crate gently hits the ground. The crate's height above the ground can be represented by the following equations. So the first equation represents the height of the crate during the free fall, and then the second equation represents the height of the crate when the parachute opens. Now, when you think about that, we've got this crate that's coming down. It's going to hit a certain point, and that at that exact point when the crate is there, the parachute's going to open. And once we have that parachute, then the crate will continue to fall. But at that exact point where the parachute opens, the crate and the parachute opening are at the same height. So we're asked to algebraically determine how long after the crate leaves the aircraft that the parachute opens. Well, if you remember, I just said that the heights are the same, so we're literally just setting these two equations equal to each other. We know that h equals negative 5t squared plus 700. We also know that h equals negative 15t plus 650. Since they both equal h, we can set them equal to each other. So that gives me negative 5t squared plus 700 is equal to negative 15t plus 650. So we're going to start by rearranging our equation. I have a t squared and I have a t, so I want to move everything to one side to make it factorable. So I'm going to have add a 5t squared here. I'm going to subtract 700, and that means I'm adding a 5t squared and I'm subtracting 700 on this side. That gives me 5t squared minus 15t minus 50 equals 0. So again, when I'm factoring, the first thing I should always be doing is looking for a GCF. I can pull out a 5. That leaves me with t squared minus 3t minus 10 equals 0. I can divide by 5 on both sides and eliminate that 5, or I could carry it along right till the end. Either way, it's going to end up being eliminated, and it does not affect our equation to do it now or do it later. That leaves me with t squared minus 3t minus 10 equals 0. And then I'm going to factor. So I would have t minus 5 and t plus 2 set equal to 0. That means that we have t equals 5 and t equals negative 2. Now, t stands for time, and while we're not given the specific units, we can assume it's likely minutes or seconds. And if I'm looking at t equals 5 and t equals negative 2, well, we can't have negative time. So this one gets eliminated, and I have t equals 5. And for the purposes of the question, we're going to assume that that's 5 seconds. Now, the next question asks, what height above the ground is the crate when the parachute opens? We're being asked specifically about the parachute opening, but if you recall, the crate is at the same height when it's free falling as when the parachute opens. So we can use either equation. I've chosen to use the parachute equation. So I have h equals negative 15 times 5 plus 650. And that gives me h equals negative 75 plus 650, meaning h is 575 meters. So 5 seconds after the free fall starts, or 5 seconds after the crate's been launched, and 575 meters above the ground, the parachute's going to open. All right, so now we have a couple examples there that relate to applications. I really hope that a lot of this lesson has felt like a refresher from grade 10, and maybe the cobwebs are kind of disappearing and things are seeming familiar. But make sure you ask questions if you have any. Take care, and we'll see you soon.